Okay. So I'm looking after it. So today, man, question. Yeah. Great. So let's start. Today our lab mainly is a lecture like. I mean, I will speak more than you will do, but it's only the first time. Starting the next class, you will work a lot. I hope so. Okay, we will start from practical arrangement or some general information. After this, about linear algebra recap. I will do it again, but in different manner. Probably I will use my slide from your first year, and also particle kinematics. Okay, task goals. So as you understood, you will have quizzes and you have home tasks. So quizzes. Each day, I mean, in the beginning of the class. So if you became late, it's your problem. And you will have 15 minutes quiz. The main goal is just to check you need to get you need to understand. Did you understand the previous material? No, it's mainly for you because it costs only 10%. It's not a lot, so don't worry. And we will have about 10 quizzes of not when about 12, something like this, but only 5 best will be, or maybe 8. I mean, so it's okay. I forgot. I wrote it somewhere, but doesn't matter. So I mean, don't worry about grade. Home task. In previously, I just in the previous year. I mean, I just gave home task and didn't check it, and they don't know material. Now I will check it. So each week, I mean, so we have Monday and Wednesday. On Wednesday, I will provide you home task. It consists of 5 tasks, but you need to solve only 3, and you need to code them. You need to write paper and I don't know, not on the sheet. It's up to you. You can write on the sheet and make screenshot. I mean, take a photo, or you can do it as a report. It's up to you. And also you need to code it. I will as you may see, I write style guide for criterion. What I'm talking about, that I will explain it later. Okay, about tools, about coding. You can use Python, MATLAB, or C++. If you want to use Go, R, or whatever, it's up to you, but I won't check your code. Okay, and report any tools, as I told you, Markdown, LaTeX, not LaTeX. LaTeX, you can open Wikipedia and it's written because it's key, it's not X. Okay, and Word, it's up to you. Formal criterion. Yeah. In general, yes. So 50% because you have this. Yes. Because you have 2 big home tasks, as I told you before. One will be on particle kinematics, and second one will be for the name. Big tasks. Each of them will cost 20%, and 10% will be weekly home task. So each week I will provide the home task. It costs 2%. It also will be the same as the quizzes. The home task helps you to understand material. Yeah, the big task, big homework, like take 4 minutes. Yeah, it's not so big. It's just you need to think. It's a difficult thing because originally when we created this task with Mololetov, okay, I will do it in 3 hours. 5 days later, I cannot solve it, and so I will help you because I will provide you the necessary information. I told you 40 these 2 big tasks. Midterms and final. So no problems. Okay. So about final criterion, I will provide you. Actually, I cannot explain it now because the final, how to say, criterion will appear when we start to solve dynamics. Now, the main criteria for now is just you need to highlight your answer. If I don't see the answer like this, я бы закрыл. Okay. Your heart should be hot. It will help you to resist. You know I am. I know that you are weak. I saw it on the training yesterday. Okay. So it's the main. About other bullets, just a brief explanation. For instance, first of all, you need to write explicitly what the object of the research. I mean, like it's a point or it's a rigid body, amount of the rigid body. After this, is it криволинейно, прямолинейно? I didn't. Yes, this linear. Sorry. I taught this course on Russian previous year. Okay, so idea. Okay, about Russian notation. I'd like to highlight it again that unfortunately for foreigners, we're in Russia. And it will affect you not only on this course, but also on the next courses. For instance, you used to know Ghost. It's like ISO, I mean, ANSI and other standards. But in Russia, we have Ghost. And I will teach you this. Of course, basics, but you need to understand because probably you should work there at least 1 year. So you need to know how to speak with others. Also, some fancy words yes for conference because I was in this situation. Then I was in Russia conference and I didn't know a lot of Russian words because I studied as a master student here. And one professor shouted at me that you get out of this place. You don't even know these basic words and blah blah blah. So I don't want that you will be in the same situation. Okay, about linear algebra recap. As I told you, we will start from cross product, line and plane, and change the frame. Also, I will give you some additional information in the last topic. Probably I provided it to you when you was my students in linear algebra, but not everybody were in my group. Okay, cross product. Actually, all the stuff we need because, as you may get on today's lecture, that he used vector product, but actually it's cross product a lot. And you need to give the intuition of it and how to calculate it. So, do you know what who can explain me that we have angular velocity? What is it? Is it vector? Or what is it? What is it? Other ideas? Normal to play. Okay. Do you agree? Yes. You're partially right. I will give you some hint. Try to think. Okay, we have force. Is vector? Okay. So what the description of it? Can we apply it to some physical place? For instance, in the box. Can we apply it to this? Yes? Okay. Can we apply angular velocity to some physical place? So it's pseudo vector. We can put it in any. So even though that we have angular velocity, we can put it in any place on the body. It's so we just it's like notation that the scientist said, okay, let's call it vector. It has some how to say benefits, but it doesn't have any physical physical meaning. So still the vector don't have it doesn't have any physical meaning. It will have because it has a big difference. You think that okay, at least I will take And as you may see, it will be useful in linear velocity, velocity, and torque, and blah blah blah. Just to make sure, like here you're using W as angular velocity. Sure. Not like in the lecture you're using W as. So about notations. Okay. As we discussed that we have his notation, yes, and common notation, and also so in actually in he mentioned a book called author was Wittenberg. So Wittenberg, actually even Malaleta, my supervisor, will say learned. Study. He uses book in his research. So he has one notation like bolt, vector is a bolt, and blah blah blah. I will provide you both notation. So you need to know that you have this notation, this notation. For me, it doesn't matter which notation you will use in your research and your report. It's up to you. But I just, let's say, I used to use another notation. I will try to handle it and try to show both notations. Okay, so how to calculate it? Classical approach, as you remember, probably this should start in his, let's say, unit vectors. Actually, as a unit vectors, he used Russian notation. E is Russian notation. And in, as you remember, I was in mathematics. So it's Russian единичная матрица. Identity matrix. Actually, it's quite helpful to understand why some notations appeared, because even in Ghost, it's Russian. Actually, but it appeared from Germany. And when you see that, okay, we have screws, we have right-handed screws and left-handed screws. So when you want to write that my screw should be left-handed, you write M9, M8. Originally, I didn't get what the hell, what is this? After this, oh, left-handed, okay. So try to, it's my first advice for you. Okay, my advice for you to get that, try to understand why this notation appears. It's like Jacobian is G because Jacobian, and so on. And screw symmetric matrix. I think it's a little bit less awkward as his slides. So yes, you just can memorize this guy, and that's it. You don't need to understand. You may understand, but for calculation you don't. Just use this guy. So this notation is a hat. It's called, at least it's from Stanford University. I took the slide from Stanford, so you may see dozens of notations. So this can we imply like the that? Who knows? Okay. Okay, so geometrical representation. Again, as we told about, yes, normal, as you told us, of the plane, and the absolute value of it is our square. And if we use triple product, in this case it will be volume. So next topic is actually, do you have any questions about cross product? I hope you remember this. Jeremy, what about you? Okay, so why do we need this topic? What do you think? Try to memorize. It was analytical geometry, as you may see. Yes, but it's like okay. What today he mentioned several types of when we talk about coordinates. He mentioned 3 possible ways. Am I right? What? We can. Yes. Fine. So actually, natural is called in theoretical mechanics. I explained you, and we had a different name. What? Parametric, yes. Not in simulation. Parametric quite widely used in CAD systems, like SolidWorks and whatever, because for computers it's much easier to calculate, because actually it's like numerical It's not. It's like numerical. I don't know, numerical method, because when you have a line and you can just discretize it, and for instance, we can describe to infinity, but for computer we can, how to say, have a bigger yes discretization. Of course, we won't see it, but for computer it's bigger than a leaf. And we do some crazy stuff. Actually, it's widely used in splines. Splines it's very polynomial curves, like this. We won't cover it because it's from card development, but you know, splines appeared when firstly they appeared when the people try to create a board, because when they try to have a fancy shape of the board, try to top view this one. How they made so they need to bend the branch. So they firstly use ropes, put like this, and put the rope, and it provides some shape. And after this, they try to bend it. So plane appeared first appeared. Sorry, Nasi, you won't see the whiteboard. Okay, so we had several type of general equation, x plus y plus t, slope, intersect, canonical, and parametrical. And of course, we can go from one to another. Is the main goal of the slides to remind you that you can do it. And we won't cover this today. You can just open slides and tomorrow, because you will need it. And just to, let's say, try again, because I put the answer. So you may just go through it and understand. I just don't want to spend time. If you want, we can stop there and try to solve it together. Henny, are you sure? To stop, or you don't want to stop? Okay, Henny. So you know, Henny said no. You're representing. No. Okay, and the change is coordinate free. Actually, you really need it really soon, and also in robotics in general. We have a classical problem. Does anybody remember homogeneous transformation? Yes. So you raise your hand. Okay, so only two of them studied in my group teams. Okay, homogeneous transformation is some kind of advanced feature which helps you to change the basis really easy, and it's coding. You can code it very fast and easy. So in general case, when we so it's our original frame. Actually, it's better to explain on robotics arm. It will be much more intuitive. It's for me. So we have base. We have arm, and it's an end effect. For instance, we want to grab some common situation probably in your MRI. So, and we know each angle. Of course, there are different notations. You can do it absolutely or relatively. Doesn't matter now, because we try to get it. Okay. For instance, is a cup. It's spray on the ground. We have a map. So, and I'm making robo brain. I don't know how it's called. Well, even in Russia. I mean, not the brain, the computer. controller in terms of control, high level control. Okay. And I say my robot, okay, you need to take this cup. So in this case, we know that it's xy. We know the beginning of the map. This is our robot, is space. Can we know this place? Of course, if we use computer vision or whatever, we can know this transformation. After this, we can know this transformation, this and this. So finally, we can find this character. But we need to return, because when we code, we need to say our angle to manipulate. The reason why we need to know the change coordinate rate. In the original case, you need to write this equation. So cosine sine about rotation, vector plus. It's not very nice idea, because when we have a lot of matrices, we should multiply, summarize, and become very awkward. It's bad idea. So some very smart guys decided, okay, let's make homogeneous transformation, and they squeeze rotation plus translation in one matrix, like this. This matrix has one more dimension. I mean, if we have 2 by 2 there, it's planar case. Now it's became into 3 by 3. Also, if we are talking about, I mean, in space, it will be 4 by 4. But you need to put 0, 0, 1. Actually, it's not just numbers. They have some, how to say, some information. But for robotics, you don't need to know it. Actually, if you remember the affine transformation, you will get what is it. Because from affine transformation, you can Google even the Google the Wikipedia page, and you can dive into the topic. I explained it in analytical geometry, but we don't need it now. So this homogeneous transformation I put there. So when we have pure translation, in this case we have then symmetry there, and we put our translation part there, and vice versa when we have rotational part, there are zeros, and we have some rotation matrix. So you can memorize it like this: rotation translation 0, 1. If you want, we can do some case study for this topic. Okay. Come to me. So let's make them very short and easy. Let's assume that it's our cell. Okay. Okay. So it's our original frame. 0, 1, 1. And point. It should be, so we rotate it clockwise, counterclockwise. X1, Y1. And for instance, it will be the vector from this part to be 0 and this 5. We know the vector 7, 4. So I want to know this A in this related over the yeah. Okay, so how you can say cosine minus sine or sine is 2/2. You just memorize it and you don't need to remember. Of course, you can find this value. Actually, in robotics, you don't need to write cos because it's too big. You just write d and s. Yes. And in the case, you write it is 90 degrees. Zero five zero five one. You write it. What is zero? Because zero, five, and one. Otherwise, you do not count. You need to put one right because we need to calculate. Zero. Actually, when you start to play, you will see that it won't work. It actually will be one. So it will always be one. Yes. And in the end, of course, you also have one. This point zero zero five and two 3D is 2D. It's plain. But we need, as I told you, in homogeneous, we need to add one. If you not believe me, you can zero in the end and check. I hope you remember how. Because today I have to memorize. Oh, I remember. Shit happens. Yes, and I draw it on my cell, and you may see that it so after this, if you decide, okay, we have a new, you know, we have a new frame, and we want to go this way. We want to go from this to this, this cross. If you want to go to this, and but you know from this frame to this frame. In this case, you just need to add new homogeneous matrix, and it will the same. Yes, and you will say this part, and you just add one. This is yes. one more addition that originally I didn't see it in other books, but in our lab we have probably not invented it actually, but he declared that you can use pure translation and pure rotation uh, homogeneous transformation. Yes. How it works? So for instance, I need to go again to manipulator. You don't need to do one homogeneous transformation, second and third complex one. What you can do? First, rotate. So R around the axis, for instance, alpha. That not of course you can put in dynamic the notation, but originally they don't use it for rotation. They don't write in this case. In their case, you need to write this table in this sheet. These four elements. Yes. I mean, represent rotate, translate, the yes, but I agree that it's here. So you will learn it on the next block. So rotate after this translate. Translate according to x. So tx was a1. After this, okay, again rotate. And so on and so on. How you can code it? You just create a function rz and one variable will be angle tx to y to z, and after this we just put these functions multiplication and that's it. You don't even need to write matrix. You just need to put like rz tx rz tx tx. You just simplify it. Sure. And also it will help you to when you will count Jacobian. Okay, now it's we can call it RAL because I spent 2 days and when I was in previous year to write these several slides. So we have three representation radius, coordinate, and natural, as we discussed. Now I will show you these slides, and after this I will open the previous slides from previous year, and we will try to say вывод. What? Derive all these today's formulas. I dislike this how to say. I just like to have my, formulas and that's it. But in our case, it will be much better for you because he didn't. At least I didn't get his slides when he used how to say stylus to write it. You will have the good. I mean, like this. Okay, so we have radius coordinate nature. So we can transform it from coordinate to a radius. Coordinate radius. AGI. And vice versa, of course. Also, we can go from radius to natural. In this case, you need to use this guy. And today you will get, because we will save some solve some tasks, why it's helpful. So you can use this equation. Integral for the path function. If you want to go from the third one, it is not trivial task. And yes, it's the reason why I couldn't solve the first big task. Because you will meet this problem. But I will explain you. Not now because you won't remember it, but when the time comes. So the from third one is optimization task. Because you need to write the function as I wrote to current position minus this function, and you try to minimize it to 0. You can try to do it numerically. I did it firstly, but my computer decided, okay, it's too tough for him. In this case, it's better to solve using some analytical, analytical functions from MATLAB, for instance, and solve it. Second is about linear angular part. The core idea, yes, that how I understood it. I tried to summarize it. Okay, we have one position type in linear R. We have one velocity type. Actually, do you know the difference between speed and velocity? Because he made a mistake. Velocity is when we're talking about vectors. Speed is all about absolute value. Speed is a model of this one. Just to clarify. So how we can so about tangent and how you can so it's in radius vector. I mean, is a form representation. It's a coordinate representation and it's say in natural way. Path function convert and we have two acceleration types, tangent and normal. So it's about this curvature. He uses word for this. And we have angular. We have one angular velocity, and one angular acceleration on a plane. Because on a space you have more. Easy to remember. 1, 1, 1. There 1, 2, 1, 1, 2. And you can easily go from linear to angular and vice versa, because you have some equations which help you to go from one to another. In this case, in most cases in a plane, you won't have cross product. You will have equations from the school, where you have just multiplication because it will be multiply cosine or sine 90, so equal to 1. And the space it won't work like. And the last one is the relation between we won't cover it today, so let's go to the. Okay, first of all, I think let's solve some tasks because you look boring. And as this, we'll go to the. Okay, you may see Henny starts to learn Russian. Okay. So actually, a lot of text, but you don't need it. Henny, you don't need to go to this. Yes, can you go to go? Go to your place. Okay. So, could you write this equation? So, they ask you to choose the 6 point and draw the function. And after this, you need to find the s. It's actually s and the natural and path. Okay. And what is that? This is the answer. Yeah, I know the answer. No, of course. I don't know what does mean this. Yeah. Okay, so you need to find the s and the path. Okay, so select 6 points. Yes. You can do it from your. Or please try to copy paste it from Almighty Henny. It's Meshersky book. Of course, you can find Reshevniks from the internet, but it won't help you. Solutions, I mean, because in Russian we how to say it's some kind of nostalgia for me. Because when I was I mean in school 5 class, 6 class, we are trying to find the solutions because I didn't have internet in those times, and we tried to find the solutions books in the shop in bookshop, and alright, I have this solutions. I don't need to do these shitty tasks with some kind of nostalgia. Did you have the same? Yeah. Yes. Get this. So you will see. And the path. So actually, try to this fancy solution. How? Okay, you don't know this equation. How can you solve it? Because actually, my problem was that when I started to solve it, I tried to solve it using this equation because I already know it, and I wrote in my cheat sheet. But you don't need to know it for solving it. Sure. Try to think. Give me, guys, any suggestions inside? Perfect. Yes. Just to draw. Yes. You have T and you have Y. For me, it wasn't so trivial because originally I just, how to say, try to, okay, I need to know this formula, otherwise I cannot solve it after this. It seems it's too complicated for this test. Why? Who told you that you need to draw a curve? What the path is? And okay, you know this equation. Okay, if you forget what does it mean, try to interpret this equation from. I will write it directly to this equation. Try to think of sure. Ahmed, what is it? Okay, what does it mean integral in geometrical way? Nice. So now you can think that when you have some, this one after this you have, and what does it mean derivative? I mean, try to combine this knowledge together. In intuition, of course, probably it doesn't work like this because I'm not a mathematician. But if you know that you have tangent, so you have some kind of curve on each position, and also you have, how to say, you have the bottom part. You try to have integral of it. In this case, you will just receive the length. Of course, it doesn't work like this, probably. What is intuition? It might help you. Yeah. What are you doing? Okay, Kenny, I'm going to help because it seems that the first task was too complicated for you. Okay, first 5, 2, 1, 2. Okay, my first part from 5 to 1, 4. After this, I'm going from 1 to 2 to 5 to 10. What it will be? 9. Because in this case, see, in this case you can get that when you want to go to this place. After this, you need to go again. Actually, in the task they ask you to draw. So after this, you're going to solve the part. And you can just if you calculate it like this, you can do it. You want to if you want to say something, you say because now we want to punch the IC. Why do you so angry? Okay, that's good. And okay. So the next task is the same. So let's go to the equations. It was some kind of break for you. Okay. Blah 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 blah. Actually, I have added the ditch there. It's not Lukashenko. My goal was ditch there. Okay. Blah 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 blah. Oh, so let's go. We have three types of motion, as I told you before: natural, vector, and coordinate. So we can write like this, and okay, try to derive it. We write it in common manner like this. Let's go derivative by on by time or on time. Or how it will be in English? To respect to t. Okay, thanks. After this, we use some magic. We put the natural divide by the natural, and we recombine it, and we have this guy and this guy. So the natural respect to t, of course, it will be the natural speed. Natural speed. And there, what is it? We can rewrite it in this manner: is a limit. And you may see that actually this delta r will be it will be really near to delta natural. And after this, we can receive the tau tangent speed. Because it will be always tangent to our vector. Did you get it, Danya? For the question. Task. So we try to handle this guy. Yes. Sigma, natural, it's path. Yes, you may see on the pictures that you have path. You have delta sigma, it's the length of the path. But delta r, our vector, RNR, it will be almost near the same. It's a limit, because it's when we discretize our task. Discretize our system, it will be near real close, and also it will be velocity tau. What? Because tau, it's our derivative of this guy, and delta r, it's a vector. It's a разница. Yes, it's parallel. You may see that delta r there and the tau, it seems parallel. And we put it there, and we receive this equation in natural. Acceleration a bit more difficult. So it's also blah 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 blah. So first step we do the same. So we receive the square, and after this we have two dots. And what does it mean? Tau respect to t. and we try to open it there. Again, using the same thing. And using this, when we will try to expand it, you will receive tangent and normal. So, is there? Because so the goal of this slide is just to show you that we have tangent and normal because not because of this magic, just magic that okay it's appeared and that's it. Just because we try to solve it. We try to uh, derive. Okay. Okay. So acceleration and this equation, how to derive it. But I put it on those slides. So all this information can be found there. There and there. Okay. Small question. Did you get what does it mean translation movement and rotational movement? Okay. Is it translational movement? Yes. Why? Because at every time, previous group didn't get it. Okay. So yeah, you're right. It is because I'm not rotating the body itself. What else? Okay, about task. I'll show you the task probably you will have. We had the problem that we have foreigners, so probably either I need to translate it or you may help them. I prefer the second one. Yeah. What again? You can find it and provide it to us. So the first task almost the same what we had. We need to find the path, find the positions, nothing special. And you can choose the task. So you have some t and need to find it. Find the velocity, speed, acceleration for each function and so on. So actually you go till Wednesday to understand these equations. I mean these formulas from these slides. So when I ask you how to solve it, you need to say that okay, I know these equations and how to correlate to each other. In this case, we can easily solve all our tasks on Wednesday. What else? Probably nothing. So just so to sum up, till Wednesday you have tomorrow. You need to again scheme the slides and get how to operate with velocities, with coordinates, and with acceleration. That's it probably. Do you have any questions? Yes. Every lab will have a quiz from yes, from Wednesday we have a quiz. On Wednesday we have a quiz. But like the quiz is about the previous. Sure, yes. Today's material yes, today's material. So we need to say, for instance, what points do you need to have a grade? uh, okay, the question was that what difference between Rizas class and our class? The first of all, you will code. On the physics, you didn't code anything. Now you will code most of your tasks. Second, it's about methodological stuff because when you try to solve, actually this course almost the same. So it may seem you for as a recap, but you need to get the deeper. Need to understand the deeper details and solve it. Okay, I know how to explain. When you need to solve some dynamics task, of course, the second part of the course will be new for you because the Lagrangian equation probably you didn't cover. Lagrangian, what else? метод виртуальных скоростей, метод виртуальных ускорений, and so on. We didn't cover it. I'm sure it because I asked the Daniel about. We didn't cover it. But if we're talking about fundamentals, so when you try to solve the task from your results class, what did you do? So for instance, we have some, I don't know. So you have, for instance, I don't know. And have some weight there. So just imagine. When you start to solve it using results knowledge, you just, okay, probably I should solve it using some technique, I don't know, some method, and start to solve it. You just try to solve this particular task. If you are in theoretical mechanics, you need to start object. Okay, my object is two, I don't know. Okay, let's assume that I need two rigid bodies, two circles, two cylinders. Research object, two cylinders. What type of movement they are doing? They have rotational movement. Okay, not rotational, also rotational and translational. It's complicated movement. Okay. So after this you need to think, okay, if we have know this and this stuff, what methods can be used? You need to try to understand, okay, I can use this method, this method, this method. After this, okay, I'm using this method. It means that I need to find this, and this. After this, okay, I need to make kinematic analysis. And you start to write the velocities, acceleration, and so on. After this, you need to make force analysis and to draw it. So it's more, you may say, okay, it's 4 examples and I don't need to waste time on it. But when you try to solve the more complicated task, real task, which I met in my research, I really get why we need to do it. So you need to understand that, and it's formal criteria, which I asked. So if you won't write it, you will have -3 from your task. So task was 5 points, you will have only 2 points, even if you solve it correctly, if you don't do like this. Is the criteria. And of course, it helps me to check the task easily. Because in this case, okay, I see this, so he didn't choose correctly the object. Okay, so I understood his problem even in the beginning. And I don't need to waste my time on look on this force and so on. So we can speak easily, so some kind of notation standard which help us to understand. So the main difference between Reso's course and our course is in standard. And coding, because we decided that, and also we're using matrix notation so because for coding it's better to use matrix instead of common equation. So it's better to write, yes, like in matrices, all your formulas instead of the like this and so on. And straight so slow linear equation. Any other question? Because do you remember all this stuff? Some of you. Yes, I remember. Any? I see you try to run away from this class. You machine is my tear. Okay. Eric. You can work with me. Okay. Who will clean up the whiteboard for you? Penny. You now would get what you should do.